Moving on to question number 7, children. That is our next question. So we'll see what it says. So in question number 7 says the length of the common chord of two intersecting circles is 30 centimeter. If the diameter of these two circles be 50 centimeter and 34 centimeter, calculate the distance between the centers. Okay, so according to the question, the figure goes like this, children. It is a common chord of two intersecting circle. Means what, children? Suppose this is my one circle and this is my another circle, and of course they are not equal circles, children. They have been given as different circles. Why? Because their diameters are different. Okay, so there is a common chord in between both of them. So this is this common chord that we are talking about. Okay, now they are saying what, children? So this is my center, this is also my center. Now the radii of the bigger circle has been given as, because the diameters of two circle is 50, so for this circle the radii will be 25, and for this particular circle, the smaller circle which is there, the radii is going to be how much? Since it's 34, so it will be 17. Okay, so this is 17 and this is 25. Now I'll be joining both of them. So basically what I am doing, from the center I am dropping a perpendicular. From here also I am dropping a perpendicular like this. Okay, so this is what I am doing. Now I will be just naming them. Let AB be the chord and let O and P be the centers. Okay, and then we will be taking the point of intersection as what, children? We can take that as C, the point of intersection of both the. So basically this is point of intersection, or simply it's the line joining the center of both the circles. Okay, so you need to find out what? You need to find out that calculate a distance between the center. So you have to calculate the length of OP. Okay, so for that what you will be writing down, write down given. What has been given, children? Since you don't have this proof type of sums, we need not write given and to prove. It's fine, we'll be normally doing. So here I have been given that OA is equal to 25 centimeter, and I have been given that AP is equal to 17 centimeter. This is already given. The distances have been given in terms of diameter, children. Then easily you can convert as radius. And now what you will be doing, you will be writing what? See, OC is perpendicular to AB. OC is perpendicular to AB, and PC is also perpendicular to AB, and this is by construction, or you can say what? Not by construction, children. Of course, when you are going to join them, this is going to come perpendicular. Why? Because perpendicular from the center of the chord bisects the chord. Okay, so this you are taking as 90 degrees. Now what you will be doing, children? See, you will be moving to, and the length of the chord has been given as how much, children? The length of the chord, that is AB, has been given as 30 centimeter. Okay, so it is understood that AC will be equal to half of AB, and this will be equal to how much? This should be equal to 15 centimeter. Why? Because perpendicular from center of chord bisects the chord. Center bisects the chord. Okay, so this you know already. So now what we'll be doing, we'll be moving to the two triangles in triangle AOC. Can you write that OA square will be equal to AC square plus OC square? So OA square is how much, children? You will be writing 25 square is equal to AC square will be how much, children? This is 15 square plus OC square will be how much? This is what you have to find out. So OC square is going to be 25 square is 625 and minus 15 square is 225. So OC square is equal to 400. So how much will be OC equal to? This implies OC is going to be equal to 20. So this particular length you are getting as 20. Similarly, we will be applying Pythagoras theorem to the other triangle as well. Okay. So what you will be writing now? See, you will be writing in triangle APC, AP square is equal to AC square plus CP square. AC square plus CP square. Okay, so AP square is what? 17 square. So write down 17 square is equal to AC is 15 square plus CP square. So this implies CP square will be equal to 17 square minus 15 square. Okay, so how much will this be equal to? 17 is equal to 17 square is 289 minus 225 is 64. So CP is going to be equal to 8 centimeter. Okay, now what you have to find out the distance. So what you will be writing down, distance between centers. Okay, so distance between centers is equal to OC plus CP, which in turn will be equal to OC you have calculated as 20 plus 8 centimeter. So this is going to be equal to 28 centimeter. Alright, so this is the way you can find out the distance between the both centers. Okay, so this was an easy one. We'll be now moving to the next question, children, that is question number 8. So in this 7th question, children, what we did, we just used the concept of Pythagoras theorem and rest of the things were pretty easy. If you are able to draw the figure correctly, then half of your sum is done. This is what I have been telling you always. Okay, so question number 8 says what? So this is our question number 8. The line joining the midpoints of two chords. Okay, so suppose this is the figure that I am drawing. Okay, joining the midpoints of two chords is passing through the circle. So suppose these are the chords which are there. So this is AB and this is CD, and then this is its midpoint, this is its midpoint. They are saying the line which is joining the midpoints is actually passing through the center. So you have to prove what? You have to prove that the chords are parallel. Okay, so how are you going to do this, children? This question is very easy. So write down, how will you write down given? Suppose you are just naming them. So for naming, we will be writing what? We will be taking this as P and Q. So given, write down P and Q are midpoints of AB and CD respectively. Okay, so this is what you are getting. Next, what you will be getting, children, see. Next, we will be writing to prove. So what do you need to prove? That AB is perpendicular to CD. Okay. So how are you going to prove that? So write down proof. So it's an easy one, children. See, you know that OP is bisecting the chord. So this implies what? That the OP will be perpendicular to AB. Okay. Write down now. OP bisects the chord. So this implies OP will be perpendicular to AB. Since line from center to the chord, or else what you can be writing in short, children, that line which bisects the line from center which bisects the chord is perpendicular to the chord. Bisects the chord is perpendicular to the chord. Okay, this is what you have studied already, children. This is the converse of our theorem. So this will imply what? This will imply, suppose this particular angle you are taking as angle 1. So write down that angle 1 will be equal to 90 degree because it's perpendicular, right? This is what you have proved. Next line, what you will be writing, children, since you don't want to write this theorem completely again, similarly, use the word similarly. So similarly, write down OQ is perpendicular to CD. So this implies, see, this I will be taking as angle number 2. Angle 2 is equal to 90 degree because it's given perpendicular. So this is your equation number 1, this is your equation number 2, and then what you will be writing, children, this is very easy, we are almost done. Since what you will be writing, since angle 1 is equal to angle 2, this implies that AB will be parallel to CD. Why? Because, children, since alternate angles are equal, that's it. Alternate angles are equal. Okay. So alternate angles you are getting as equal. So therefore the lines will be parallel. Alright. So this was very easy one, children. You only need to prove that since it's passing through center and it is bisecting the chord, therefore it is perpendicular to the chord. Alright, so now we'll be moving to the next question, that is question number 9, the second last question of this exercise. So question number 9 says what, children? It says in the following figure, the line ABCD is perpendicular to PQ. Okay, and then where P and Q are the centers of the circle. Okay, so this is our first circle, then we have another circle which is pretty smaller. Okay, and then this is my center P and this is my center Q. So what I will be writing, this I will be writing as P, this I will be writing as Q. I will be joining both of them. This is what the figure has been given, and then what has been given is, children, if you just look into the figure, it goes like this actually. Okay, so this is A, this is B, this is C, and this is D. This is point P, this I have written already. Okay, so now what you need to do, you need to find out, so this is our question number 9. So in this particular question, you need to find out what? You need to prove that AB is equal to CD. What else has been given? What else you have to prove? That AC is equal to BD. Okay, so write down given. Write down what all things have been given, children. If you just see, in the given part you can have ABCD is perpendicular to PQ. Okay, so write down AD is perpendicular to PQ. Okay, where P and Q are the centers of the circle. Alright, so what you will be taking, children, for your ease, you can take the point of intersection as O. Okay, so this is what. So now what you can be writing, you can be writing like this, children, so that it is still more clear to you. So it is given that OP is perpendicular to AD, and separately write down OQ is also perpendicular to AD. This is what is given. So what do you need to prove now? Write down to prove that AB is equal to CD. This is what I am writing. So do you need to do any construction, children? No, you need not do any construction. So we'll directly move to the proof part. So what is the proof here, children? In the proof you will be writing what? See, OP is perpendicular to AD. This is given already. And then what you will be writing, this is for which circle, children? Okay, see, not OP, children. Okay, this has been written wrongly. I'll just correct it down, children. This was right, but the names that you have to take has to be right. So you can see OP is in the smaller circle. So you have to write what? That OP is perpendicular to actually BC. If you see in the circle, and here you will be writing that OQ is perpendicular to AD, sorry. This is what you have to write because there are two separate circles. So now what you can be saying, you can be writing like this, since we are having two circles. So write down in smaller circle. In smaller circle. Okay, if you see, this is my smaller circle, children, that I am talking about. I'll be writing down OP is perpendicular to BC. So this implies what? OB will be equal to OC. And what is the theorem, children? The theorem is perpendicular from the center bisects the chord. From the center bisects the chord. Okay. So this particular statement which is there, children, this you will be taking as equation number 1. You are getting OB is equal to OC. Now what you will be writing next, children? You will be writing in bigger circle. Okay, so write down in bigger circle. What you will be writing down? In bigger circle we are getting that OQ is perpendicular to AD. Okay, so will this imply? So this will imply what? That OA is equal to OD. And the reason is same, children. Perpendicular from the center of the chord bisects the chord. You can just write it down. Okay, so this you are going to take as equation number 2. Now what you will be doing, if you write down equation 2 minus equation 1, what are you going to get? What is our equation 2, children? So you will be writing OA minus OB will be equal to OD minus OC. So if you see OA minus OB is equal to what? Write down, this implies AB is equal to OD minus OC, if you see is CD. So this was the smaller one. That's what you had to prove, right? AB is equal to CD. Okay, so there goes your first sub question. And then for the second sub question, what are you going to write, children? This is also an easy one. Okay, now write down AB is equal to CD. This is what you have got. Now you will be writing adding BC on both sides. BC on both sides. What are you going to get, children? You are going to get AB plus BC is equal to CD plus BC. So this implies AB plus BC is equal to how much, children? If you see, this is equal to AC, and CD plus BC is equal to BC. So AC, okay, sorry, CD plus BC is equal to BD. Okay, so this is what you had to prove. So this is hence proved. So this was very easy one, children. Only you should know what you have to do and what you need to find out. Alright, so we are done with this question as well. We will be now moving on to the next question, that is question number 10. Okay, so question number 10 is an important question, children. You can just mark that as important. Okay, so what does this question say, children? This is my question number 10. It says that AB and CD are two equal chords of a circle with center O. Okay, the figure has not been given, but then they have been given and they are intersecting at right angles, children. Alright, so this is our figure like. So suppose this is my circle that I am talking about. So there are two chords AB and CD and they are perpendicular to each other. Okay, and then here O is my center, suppose. So this is my AB and this is my CD and they are intersecting at point P. Okay, and this P is 90 degrees. Now what they have given, two equal chords with center O intersect each other at right angle at point P. If OM is perpendicular to OB, alright, so this is also given, children. We have a point here OM which is perpendicular to AB and I have a point here ON which is perpendicular to CD. So you have to show that OMPN is a square. So this is your figure like. Okay, so children, if you see here that this is also 90, this is also 90, this is also 90. So if all the angles are 90 degree, so you can just conclude that this can be a rectangle, because for a rectangle all the angles are 90 degree. But then you have to prove that it is a square. So proving it as a square, you have to prove that any two consecutive sides, okay, they should be equal, because you know that in a rectangle the opposite sides are already equal. But for proving that it is a square, you need to prove that even the adjacent sides are equal. Okay, so how are you going to do this? Just write down given. First of all, AB is equal to CD. This is what has been given already. Okay, and then what else has been given? That angle P is equal to 90 degree. Okay, and angle OMN, not OMN, write down children, OM is perpendicular to AB. Okay, and ON is perpendicular to CD. This is given. Now what do you need to prove? To prove that OMPN is a square. Is a square. Okay, so in the construction part, what you will be writing? Write down construction, join OP. Join OP. Okay, so this is what you will be writing. So you are joining OP. Okay, why am I doing this? You will be just coming to know. So the main reason is, children, okay, we'll just write down and then we can just know. So write down in the proof. See, write down angle P is equal to 90 degree. Okay, this is what is given. First you have to prove that it is a rectangle. Okay, and then you can write down what? Angle P is equal to 90 and angle OMP is equal to angle ONP is equal to 90 degrees, since OM is perpendicular to AB and ON is perpendicular to CD. Okay, so you conclude that this is, so this implies what? This implies that angle O will be also be equal to 90 degree. Why? Because sum of quadrilateral is always equal to 360 degree. So if three of the angles are 90 degrees, so it is understood, children, that the fourth angle also will be 90 degree. Okay, so why are we doing this? So what you will be writing? This implies that OMPN is a rectangle. Okay, so you are proving that it is a rectangle. So how is that going to help you, children? If you are proving that it is a rectangle, therefore what you can writing? This implies that OM will be equal to PN and MP will be equal to ON. Okay, and the reason is opposite sides of rectangle are equal. Okay, so this is what you are getting. I'll write down here once again that you are getting OM is equal to PN and you are getting MP equal to ON. Okay, MP is equal to ON. So this you will be marking as equation number 2. The reason I have written, children, that you have already proved that it is a rectangle and you know that the opposite sides of the rectangle are equal. Okay, so this is what you are getting, and now we'll be doing what? We'll be moving to the next part now. You have already proved that these two are equal, opposite sides are equal, but now that is not enough. So you need to prove what? That even the adjacent sides are equal. So we'll be moving to the next part. Okay, so write down given AB is equal to CD. This is what is given. So this implies OM will be equal to ON. Why? Because write down equal chords are equidistant from center. Equal chords are equidistant from center. Distant from center. So this is what is the next thing. Now what you will be writing, children? You will be writing that since they are equidistant, so you are getting OM is equal to ON. Now we will be moving to the triangles. So what you will be writing in triangle OMP and ONP, OMP and triangle ONP. The first point what you can write is OM is equal to or we can write the right angle part, children, that also will be fine. That angle OMP is equal to angle ONP. Why? Because it is already given that both of them are perpendicular. The second part that you will be getting is OP is equal to OP. Why? Because, children, that is common. Okay, and the third part which is there, children, the third part you can be writing that OM is equal to ON, and the reason is you have just proved above. Okay, so now what you can be writing, write down, therefore triangle OMP is congruent to triangle ONP. By which congruency, children? Clearly by RHS. Okay, so now what you can be writing, if these two triangles are congruent, then it is evident that PM will be equal to PN. Okay, so this implies PM will be equal to PN. So this is by CPCT. Okay, so this you will be taking as equation number 2. Now what you can see, children, here, that PM is equal to PN. So can you say, children, if PM is equal to PN and these two L's are in turn is equal to other sides, so can you write, see, from 1 and 2, from 1 and 2, what am I getting? I am getting that OM is equal to PN, okay, and MP is equal to ON. Further, what I am getting? I am getting that PM is equal to PN. So what you can see here, children, PM is equal to PN. If these two are also equal, means what? This implies that all the sides are equal. So you can write, this implies PM is equal to PN is equal to ON is equal to OM. Okay, so you now have proved that all the four sides are equal. So now what you will be writing, therefore OMPN is a square and the reason is, since all the sides are equal, and each angle is equal to 90 degree. Angle is equal to 90 degree. Okay, so you now have proved that the given figure which is there, this is OMPN, is actually a square, because you have already proved that each of the angles is 90 degree and each of the side is equal. So which is the quadrilateral whose all the four sides are equal and all the four angles are 90 degree? It is nothing but a square. So you are proving that this is a square. So this is what you have to prove. Alright, and now what will, children, we can see that we are already done with all the questions of this particular exercise. Now what we will be doing, children, we will be going to the next topic, which is arc and chord properties. Okay, so this is also an interesting one, children, so you just have a look into it. We'll be just discussing the facts which are there, and if then questions related to this we can be looking in the next session. Okay, so this heading is called what, children? This heading is called arc and chord properties. It's okay, I can just write it down like this. So this says arc and chord properties. So you now already know what is arc, children, and you also know that what is a chord. So if you remember, children, in this particular circle that I have drawn, any part of this particular circle, so suppose this part of the circle, if I am talking about, this can be my arc, this particular part can also be my arc, this particular part can also be my arc. Okay, so the first thing which is there, that equal arcs cut equal chords and equal chords cut equal arc. Okay, so this means what, children? Suppose this is my circle that I am taking. So now in this, if the first thing is equal arcs cut equal chords, so suppose length of this arc, okay, is equal to length of this arc, children, then it says what? Then this length of this chord will be equal to length of this chord. Okay, if the length of the arc is same, then length of the arc is same, yes, then the length of the particular chord will also be same. Okay, so this is one of the important properties, children. And the converse is also true, children. What do you mean by converse? The converse says, suppose in this circle, if this chord is equal to this chord, then the length of this chord, that is this particular part, this arc, will be equal to length of this arc. So these are the two important properties, that if the length of the arc is same, then the length of the chords that they are subtending is same. Or what is the next one? The next one is, if the length of the chord is same, okay, then the length of the arc is also going to be the same. So this is basically what? This is the converse of the statements. Okay, so this is what is the first property that you need to remember, children. If I just want to revise once again, you can look into it. It says that suppose this is my circle, I'll be drawing two circles. Okay, so in the first circle I'll be saying, if the length of this arc is equal to length of this arc, okay, then the length of this chord will also be equal to length of this chord. Okay, so this is the main statement, and the converse says, if length of this chord is equal to length of this chord, then the arc that is being subtended, the length of these two arcs is also going to be the same. Okay, so this is the first property. We'll be now looking to the next theorem that is there in your textbook, children. That is very important, and that is the main base of your next exercise. So it says, if two arcs of the same circle subtend equal angles at the center, they are equal. Okay, so what does this mean, children? This means, suppose I have a circle. Okay, and then what do you mean by arc subtending an angle, children? Suppose this is my arc and this is my arc. When we say that arc is subtending an angle, children, suppose this is the thing. Okay, this is what is arc subtending an angle. So they are saying that suppose this angle is equal to 30 degree, and if this angle is also equal to 30 degree, then length of my arc APB suppose will be equal to length of my arc CQD. And you have to remember that the arc is basically denoted by three letters, children, because if you are going to write only AB, that will become what? That will actually become a chord. But here we are not talking about chord, we are talking about an arc. Okay, so this is what is there. We'll be moving to the next thing, children, that is completely converse. So it's according to this statement, if angle AOB, okay, is equal to angle COD, so this will imply that measure of arc APB is equal to measure of arc COD. Okay, so these are the two important things, the one important thing for sure. Now what I'll telling, children, I'll be talking about the converse. The figure for the converse is also same, and as the name suggests, this is just the converse. So converse says, children, that if two arcs are equal, means what? Here you have already given that if APB is equal to CQD, then the angle subtended by both of them will be equal. Okay, so if I just want to draw through another figure, it says that suppose, children, if this particular arc is equal to this particular arc, then the angle that is being subtended at the center by both of them will be equal. This is 30 degree, this also will be 30 degree. Okay, so you now know what is the condition, children. So I'll be writing down both the cases here so that you understand. So this is our main. So according to the main statement, it says, children, if angle APB is equal to angle COD, so this implies that length of measure, not measure, children, this is actually length. So you will be writing that APB, arc APB will be equal to arc CQD. Okay, so this is my first statement. And if I talk about the second statement, that is converse, it says that if arc APB is equal to arc CQD, okay, I'll be writing down this, that if arc APB is equal to arc CQD, so this implies what? This implies angle APB, okay, I'll be writing down here, angle APB, AOB will be equal to angle COD. Okay, so this is the converse. So this is a very important thing, children, that we'll be using in the next exercise. So it is very important for you to actually understand this particular theorem. Okay, so these are the important theorems. The proof of them, of course, it's not important, so we'll need not go into that. So before proceeding to exercise, there are other things that I want to tell you, children. So in the other things, there are certain things that have been given. Suppose this is in circle. Okay, so in this circle, suppose this is my length of arc APB. Okay, and suppose this is my length of arc CQD. So clearly you can see that CQD is bigger. So it says that if arc CQD is 2 times the arc APB, then what does this mean? The angle that they are subtending, that is also going to be twice the other. So this implies, what is the angle subtended by CQD, children? If you look into this figure, the angle that is being subtended by CQD is equal to angle COD. So this means angle COD will be equal to 2 times of angle AOB. So this is an important thing that you need to understand. Alright, and then what is the next statement that is there, children? According to the next statement, similarly, if arc CQD is equal to, suppose 3 times of arc APD, so this implies that CQD is subtending angle COD, this will be equal to 3 times of APD is subtending what, children? APB, sorry. So this will be 3 times of angle AOB. Okay, so this is one concept. Now one more concept that is there, children, is in terms of ratio. So in terms of ratio, it is like, children, see, if arc APB is to arc, suppose the ratio between them has been given, is to arc CQD is equal to, suppose it is 3:5. So this implies, children, the ratio between the angles that they are forming. So APB is forming what, children? This is forming AOC. So you'll be writing angle AOC is to angle COD. The ratio between them also will be equal to 3:5. So this is very important thing, children, that you need to consider, and this is important not only because this is there as a part of a theorem, but then in the next exercise that we'll be moving into, that is exercise 17C, this is a question, this is the base that you are using. If you don't know this concept, then that will be difficult for you. Okay, similarly, there can be a sum of this type, children, which I'll be showing you right now. See, suppose this is our circle and this is my diameter, and I have been given that suppose this is APB and this is BQC. So I have been given, suppose, that arc APB is to arc BQC is equal to, suppose it has been given as 1:2. Okay, and then if suppose they have given that AC is the diameter, then they are asking you to find the measure of this particular angles. Then how you are going to find out? You will be writing that arc APB is to arc BQC is 1:2. So that is understood, children, that arc APB is subtending what? Angle AOB is to angle BOC will be equal to 1:2. Then what you can write, using common ratio, you can take AOB as x and you can take BOC as 2x. Okay, then you can easily find out, since they are saying that it is diameter, so it is understood that it is going to subtend an angle of 180 degrees. So you will be writing x plus 2x is equal to 180. So 3x will be equal to 180. So x will be equal to 60. So this will be 60 and this will be 120. Okay, so what do I mean to say, children, that whatever questions that you are looking into, they are really very easy. The only thing that is tough is the thing that you should actually know this concept, because if you don't know this concept, then you cannot possibly solve these questions. Okay, only one more thing is there, important children, that I'll be letting you know. So according to that concept, it says, suppose, children, if an n-sided regular polygon is inscribed in a circle, then angle subtended by each arm is equal to this much. So suppose there is a triangle, children, okay, sorry, circle. Suppose in this you are inscribing a triangle, then what is the angle subtended by these sides, okay, will be equal to, the formula says what, this angle, suppose this is my triangle ABC. So since the number of sides in a triangle is 3, so this angle will be equal to 360 degree divided by n, and n is equal to 3, so 360 degree divided by 3, which is equal to 120 degree. Okay, so there are two things that are important in this particular property, children. The one thing is that it should be a regular polygon. So what is a regular polygon? Whose all the sides are equal. Okay, and the second thing is that the angle should be subtended by the arms. Okay, so if I just want to explain this with the help of one more example, children, it goes like this, that suppose this is my circle. Okay, and in this I am inscribing a pentagon. Okay, so what will be the formula? The formula is 360 degree divided by m. But what is this formula, children? It means that any one arm of this pentagon is going to subtend an angle which is equal to 360 degree divided by n. So here it will be 5. So this is going to be 72 degrees. So this angle should be actually equal to 72 degrees. Okay, so this is what you are getting. And then similarly, children, we can be talking about any n-sided figure. So another n-sided figure, if you want to take it, so this is my suppose circle, and then if I am drawing a hexagon into this, so what will be the angle that is subtended equal to, this angle subtended to the center by each arm will be equal to 360 degree divided by 6, which is equal to 60 degree. Alright, so the questions related to this will be looking in the exercise as well, children. So the exercise part will be looking into the next session. Alright, thank you, students.